Good morning. I don't know what happened with the link. For some reason, it was not there.
Good morning.
Yeah. So for some reason, the link was not there. And quite a few of you were sending about it. And then right now it appeared. So I don't know what's going on with this Canvas right now. So anyway, so let me go back and answer some of you who are sending messages.
Or if there was a problem with the link right now.
Yeah, seems like. So let me send a message. Let me pause the recording in here while I'm doing. And good morning and welcome to Astronomy 100. Today is actually August 23rd. And we have quite a few things to cover today. So I just want to get started with this thing. So hopefully let's make sure that the link, everybody is getting to it right now. For some reason, it was not working earlier. So go back to home in here. And let me switch to student view to make sure everybody is looking at the same thing in here. So for those who are not, who had problems before and they couldn't log in, they can actually, if you come in late later on, you can always watch the recording, or at least the portion that you missed. So to make sure you don't miss any assignments and questions. As a matter of fact, there is item 1 of the discussion that is going to be immediately the first one to talk about, and it's extremely important. I really need to know where you guys stand in terms of Stellarium, because last week I talked about Stellarium, and I showed you guys on Canvas, on the syllabus, where to go and find it. So let me go back and share with you the screen to make sure that we're on the same page. Everybody is doing the same thing. So I should be sharing this screen in here that shows the view from the vantage point of the student. Obviously, this account is not a real account, so it's just for testing purposes. So if I go into the syllabus again and scroll down until I find textbook and other resources, it gives you the textbook that is required for the class. And some of you already communicated to me saying that they are having difficulty with the 5th edition versus the 6th edition. Both of them should work, and up to this point, I did not see any difference whatsoever. So, and I have both of them. So I will pinpoint anytime there is a difference between the two. I will tell you which one to find where. Okay. Anyway, the software is here. It's called Stellarium. So if I click on it, it should take me to a page that looks like this. Okay. I may have to stop sharing again and share with you the page to make sure that you're looking at the same page as I am, because sometimes when I click on something, it takes me completely out of that. Anyway, the software looks like this, or at least the page, when you go to it, the link, when you click from the syllabus, it takes you to this page. I would assume that if you have an Apple, that you already was able to install it using this link. If you have a Windows machine, either of these two should work. One or the other should work, depending on the version of Windows you have. So most of the time, this will work on either, okay? So that is if you have a Windows machine. Now, in the rare occasion that you have a Linux machine, one of this also should work, okay? So you should have had this software installed on your computer. If for some reason you are not an admin on your computer, you don't own the computer was loaned to you, for example, from the college, and they gave you, they put restrictions on it so that you don't install stuff. If that's the case, then you can still use the software using the web version, the Stellarium web. So the first item of the discussion today is to tell me that are you ready for Stellarium, yes or no? Okay. either you state that you have installed it on your computer successfully and tested it to make sure it's working and you are ready, or you have gone to the link for it and you are ready and you are basically, you tested it and everything is ready. So one of these two should happen. Or if for some unforeseen reason you cannot install the software and you still cannot access the web page, you need to let me know that too. So I need to know where you stand on Stellarium. So this is item 1 of the discussion today. Is this clear? At least for those who are here. Okay, very good. So at least one person, so hopefully everybody is on board in here. Okay, so this is item 1. Item 2 also, there's still not, that's the only item for the discussion so far. You will have probably others, okay, down the road. So I'm going to go back to home in here to show you the couple of changes that happened from this module for this one. In terms of the work, first of all, yes, there are stuff that is required, but you have to make sure you do all of the activities. For one thing, it gives you the terminology for this entire chapter. So you really need to make sure that you know what this terminology is, what these words are. You should read, you should have read units 1, 2, and 3. All of those units, you should have read them. In order to help you with the reading, there is this recordings that I made from related to week 1's units. This is not a replacement of those readings. You still have to do those readings. But this helps you, in a sense, to go through those readings and see the insights. There is a 10-minute, basically, version for each unit in this review in here, and that covers all of these 3 units. So I expect you guys to do the readings first. Then, if you need to, you can come and watch these recordings, or do them whichever order you want to. So this is the bulk of the matter. This is what we're supposed to be doing in this class. So this is where you're going to be tested on. Okay, so this is the things where it matters a lot. So I really want to make sure that you guys are doing the readings, and if need be, the week after, I will record my take from those readings. Those readings. Understand the following. My interpretation is, in a sense, sometimes is an exploration of some of the concepts. I don't really go in detail about this one. Some of them I skip them because I think that probably you don't have a problem with them. Now, sometimes things that are further explored there in this recording. So you really still have to do those readings, because sometimes you will discover something in there that I did not talk about, and later on it's tested on. So it's very important that you do the readings for these units. So this is important. Come in later on and watch the recordings if you like. They are 10 minutes each per unit, so it should not be really that much, 10 to 12 minutes per recording. Per unit, so it should not really be hard for you to follow and do those things. So that is from the week 1 review. Okay, this is again today's discussion session. So that is when you're going to either go in here and answer the prompt. So far there is only 1 prompt, so do not start answering yet, because you might have another one. And the first prompt, if you guys, just another reminder, has to do with Stellarium and how far you are in your readiness for it. Okay. Then obviously we have the next 3 units, which are, you're supposed to do the readings for them from this chapter still. So 4, 5, and 6. And today I'm going to go still on this ones. This is not a graded assignment yet. This has to do with Stellarium. The activities in this assignment have to do with what you read in here. So this is, again, you're going to open Stellarium and you're going to go step by step and follow. Do not skip the steps. If it had tell you to hit the letter P, then the letter K, then the letter C, just do it in this order. If you think that you have things messed up, that you probably started with the letter K and then you went back to the letter P when you're not in order, you can always restart the program. If you think that you are in the wrong place, because at some point you're supposed to focus on the sun and watch the entire constellations move around it, and so that you're still centered around the sun. So this is basically what, then if that's not happening to you or for some reason, and sometimes it tells you to hit the letter L about 6 times. But let's say, for example, you hit it 8 times, 9 times, 10 times, you will see the screen going so fast and you will lose track of what, you'll get dizzy. So what you do in this case is probably you can go back and slow it down. There is a letter for it to slow it down. And if you think that it's not slowing down enough for you, just close the whole thing and restart again. Okay? So this is the purpose of which to get you familiar with the concepts covered in there, and also more and more on your own, basically, activities that has to do with Stellarium, because there is a graded assignment that is coming down the road. So I want you to really be at ease with this application in here. Is everybody on board, at least from the few who are here, in terms of what I'm talking about? Okay, very good. Thank you very much, Francisco. So what that means is you are, first of all, the first assignment for the first discussion point from today is to tell me where you stand in terms of Stellarium, follow the items in this week's assignments, and then answer and do the activity on your own, okay? Now, there is an assignment due this week, and it's a big assignment. Some of you did not submit it yet, and that is the 26th of this month, which is the Thursday, 26th. So I want to remind everybody, and I'm going to send a reminder to everybody that there is a deadline coming this Thursday, and that assignment is critical because it is graded, first of all, and the grade is very high. It's not a small 5-point grade. It's 20 points overall when you complete both parts of it. And also, it may have implications on where you stand in this classroom, because we are required to report attendance to the college, and to not be dropped from the class to show that you are actually doing what you're supposed to be doing in this class. This is, I'm going to be basing your attendance based on that. Because as you can clearly see, this is not a live class where I take attendance. This is a class where it's online and you may come in at any time and start doing things. The only way for me to know for sure that you're doing your tasks, this is the first one. This is the one that is going to drop you from the class if you don't complete it. So I want to make sure that everybody is clear on that. It's not just a grade, but it's a matter of where you stand on the entire class. You may be dropped by the drop date, okay? So make sure that everybody responds by August 26th for the first part of it, and August 28th for the second part of it. And all of these things sound technical. I mean, it sounds like a kind of going around these concepts, but it's very important, okay, that you guys do this. So those are the things that I wanted to emphasize on. This recording is going to be posted later on Canvas. And for those who are not in here, they should also be on the same footage, on the same basically same chance basically to make sure that they are not dropped and they will be surprised later on. Okay. So this is in terms of both things. We have this discussion. We have the discussion from the week before, of course. That's going to be a habit now. And also we have the item today, which is going to be here, in addition to the assignment from this one that is due, the first part of it this Thursday and the second part of it this Saturday. So this is where we stand on these things. Obviously, we still have more stuff to do. We still have more work to do. And let me cover briefly what these 3 units cover, so that when you go and do the reading, at least to have these things, what to look for this week. And if you did not do the readings for these units, that is, you have to do them. You have to do them, and this recording should help you throughout these readings. So let me stop sharing this screen in here. Oops. And let me share with you another screen in here. Let me pull it first from Unit 4. So this is unit 4. Is this unit 4? Yes, this is unit 4. And unit 4, let me make sure that I have all of the units lined up, because it looks like this is unit 5 and this is unit 6. Yes. Okay, so these are the units that we're going to be covering in this week. Okay. Unit 4 deals with the fundamental forces in, first of all, the objectives. Okay. The objectives are the following. This is what you're supposed to be doing in this chapter. First of all, this part of the chapter describes the scientific method and the process involved in it. It's like an algorithm, step-by-step recipe, for example. When you are trying to make whatever you want to make, the best breakfast that you usually make, or whatever recipe you would want, whatever thing that you want to do, usually there is a step-by-step process involved. Okay. The only difference in here, it's a very important one, is sometimes it does not happen in the order that is prescribed. That's all. Okay. So sometimes, instead of putting the salt first and then followed by the black pepper, you might do it in the other way. It might happen naturally in the other order. So the scientific method is one of the things that you're going to be learning throughout this course. There will be practical examples of this. We come up with a model for whatever concept we want to build, and that model may be working with the assumptions that we have or the hypothesis that we made, and then later on a new experiment or new observation basically questions the model itself. Okay, so what in this case we will do, we come up with another hypothesis, okay, and we test it. Usually when we test the hypothesis, we test it for to try to prove it wrong. Okay, until it's proven wrong, then it may be solid. Okay, we develop a theory later on based on that work, and the theory is the body, the collection of knowledge that we gather around those assumptions. So that is really something that you have to. A word of caution in here also, a theory in this sense is really much more than the everyday idea of what the theory is. When somebody tells you I have a theory, sometimes they really mean I have an opinion, okay? An opinion, my opinion may be different than your opinion, except that in science, a theory is far more than just an opinion. It's actually based on a lot of experiments, a lot of observations that come up with that theory. Case in point is, when we're going to talk about this one later on, dark matter, for example. Right now, there is a lot of evidence, not just one, a lot of evidence that solidifies the existence of dark matter. So the Big Bang Theory, for example, it's not a matter of opinion. There is a lot of experiments and a lot of observations that really puts it together, and that led to a lot of explanation of other phenomena that we couldn't explain. Okay, one of them is the expansion of the universe and the rate at which it's expanding. So these are some of the things that we're going to be covering throughout this course, and the scientific method is at its core. So what I'm hoping to achieve from this one, and what this book actually hopes you to achieve from this one, is to borrow these ideas. And when you are talking about with people and about ideas that may be scientific, put it to the test. Put it to the test. Like, for example, the whole topic that is due this Thursday, August 26th, has to do with a flat Earth. Is the flat Earth an idea that can be can satisfy the scientific method or not? And you will see it does not. Okay, so that is one of the things that you would want to take from this one. So the scientific method is an important one, and then it gives you the process in here for it. And also in this unit, we'll talk about the atomic model, the periodic table. If you have had the chance to go to any laboratory in chemistry, sometimes in physics too, you will see the periodic table of all of the elements of them. And in this unit, you will discover some key concepts in here, especially the atomic mass and also the atomic number and what they mean, number one. Number two, also, you will see the elements where they were formed initially, where they're part of the initial, basically, things that were formed immediately after the Big Bang, how much they're abundant in the universe, and so on and so forth. So those are some of the properties that you need to pick up from this unit. And also, list of the fundamental forces of nature. Turns out that there are 4 of them, 4 forces. Okay, there is from order of strength to weakness. The strongest one is the so-called strong nuclear force. That is the strongest force, okay? Followed by the electromagnetic force, the force of electricity and magnetism. That force is responsible for most of the things. All of the things, the electronics and everything else is based on it. The nuclear force is really what holds the nucleus together. Without it, of course, we cannot have nothing, including us in here. And then, like I said, the electromagnetic force, electricity and magnetism, and then comes the nuclear weak force that is responsible for radioactivity and the heating of the core of the Earth, followed by the force of gravity. And if I put them this way, it seems like there is 1, 2, 3, but actually there is 1, and then 100 steps later there is 2, and there is thousands later there is the weak, and then you have to go very far in line, extremely weak force, which is the force of gravity. Yet the force of gravity is what holds the universe together. For some reason, the guy who's doing the grass decided to come. Okay, hold on. Okay, let me pause quickly to close the window, and I will be back. Okay. Sorry about that. Hopefully it's better now. Anyway, so those are the 4 forces in nature, and describe how particles interact depending on their mass and kinds of charge. So this is again, as the first one is the the gravity, and the second one is the electromagnetic force. Okay, so these are some of the first things that are covered in this unit. Then let me stop sharing so that I can share with you the second screen for the second unit, unit 5. Let me go to the objectives of this unit and share. So this is again unit 5. This is what you're supposed to be reading throughout the book. Okay, do not rely on the PowerPoints or my recordings later on for them. So you really have to read these units from the book. That's why the book is important. You have to have the book no matter what. Okay. So it's in addition to assignments that are coming from it. So describe the celestial sphere and explain what it makes it useful to model a useful model of the sky. So basically, if you go outside tonight, you will see that there is a dome. You can model it as a sphere. It's not real though, because it has a depth, okay? So it's not really a sphere of a certain radius, okay? But it's really useful one because we can locate objects on it, basically just by looking at which direction to turn from the east, for example, or from the north, go east 90 degrees, that's east, go another 90 degrees, that's south, go another 90 degrees, you're in the west, go 90 degrees, you are in the north, back where you started from, 360 degrees. Also, you can look up from the horizon, look up straight to the top of you, that is the zenith, that is actually 90 degrees from the horizon, and then another 90 degrees takes you back to the horizon and behind you, okay? So you can go from 0 to 180 degrees. So it's 180 degrees one way, and it's 360 degrees the other way, and you have covered the entire sky. If the Earth was not there, then you can go below to the opposite point to the zenith and so on and so forth. So this is basically how you discover, and you can locate objects in the sky. And this is part of the activity that you will do in here. Again, the terminology used in here and how objects move according to their latitude and longitude, and estimate the position of objects on the celestial sphere using its coordinates, basically the two angles, okay? Again, we're not going to emphasize on a lot of the terminology in here, which seems to be hard, but I hope to, when you guys do the Stellarium activities, you will have an appreciation of this celestial sphere and what it means and so on and so forth. Because at some point in the activity, you're going to turn on the ecliptic and you will see the sun actually moving on the ecliptic. And that is actually because the Earth is actually moving in there, and you will see that whether the moon or Mars or Venus or Mercury, because you will hardly see anything else because the others are very far away. You will have to wait a long time, over at least a whole season, basically from spring to fall to winter to summer, to see the other, namely Jupiter and Saturn, come into view, okay? Because they're moving extremely slow, relatively speaking. It takes 12 years on Earth for 1 year on Jupiter, and that is actually less than that of Saturn, let alone Uranus and Neptune. Okay, but the others, so 1 year by, you will see them actually dancing on a daily basis, especially the moon. You'll be actually, you will see it flying in the screen in there. So when you do the activity. Again, so those are, you're going to appreciate what this means when you do the activity. So I'm hoping that you guys do the activity also and you have resolved whatever issues you have with Stellarium. So this, the last unit in here, let me put it first of all. Unit 6, let's go to the objectives. And let me share with you the screen. Here is the second item of the discussion today. Once you read Unit 6, you will have gathered enough materials. Then the promise is you do the activity that is actually the last one immediately after Unit 6. It has step-by-step, basically a prescription of what it needs to do. You should understand what these things are, okay? You should have an understanding of, describe the annual motion of the sun relative to the stars on the horizon, and you will see that, okay? First of all, do the reading, and then do the activity, okay? Recall the dates, names of the sun, and then you see the signs of the zodiac and the ecliptic and all of these things. So that is really what the problem, explain how the solar system heating varies during the year. This is part of the readings that you describe the Earth's precession and its effects on our view of the night sky. Of course, the Earth is really, yes, it's spinning, but it's actually precessing. It's also doing another rotation around the axis. So you really need to read these activities, read the chapter, read the units in here, and do the activity. So that is the second item of the discussion, is that you have completed the units and also did the activities. And if you run into some problems, please let me know. So the second item of the discussion is I will do the reading for this units and then complete the activity, okay? Because they're intertwined, they're connected. You guys understand the second item of the discussion today? Okay, thank you, Ricardo. Okay, so we know what we have to do. So the first one has to do how you stand in terms of stellarium. This one, how these two things are connected, and at least you promise that you will do them. I know that the reading sometimes takes time, and the activity, you may run into some situations where you thought you did it in proper order and then things are not working, because I did the actual activity step by step myself, so I know it works, okay? So if you have run into some difficulty, that is something that I need to know about to make sure that you are completely at ease and in control of the situation, okay? Sounds good? Okay, very good. At least for those who are here, everything looks good. Okay, so let me, in preparation for the next level of assignments that we need to do, and namely, we're going to do some numbers. We're going to be plugging numbers. So in addition to the discussions items that we've been discovering and playing with, we have the units we're supposed to be reading and also doing the activities related to them. That is another level. And now there is a third level, and I promise this is it. And that's the last level of how much activities you're going to be doing, how much stuff you're going to be doing in this class. So item 1 in this class, you're doing the discussions and making sure you're participating and involved and doing all of the stuff you do in the class. Item 2, you're doing your readings as prescribed, and also completing the activities. So those are 2 things so far that we have discovered in this class. The third things I'm going to introduce right now is the kind of math and the kind of calculations that we're expected to do in this classroom. Okay. So let me pull the book. It doesn't matter which version it turns out, both of them are on the same pages. So I'm going to pull the 5th edition. And I'm going to go to Unit 1. And see if we can do this activity together, okay? If we can do these calculations together. And if you are having difficulty with the math, please let me know, okay? The last thing I would want you to do is be frustrated with the math because it's supposed to be a tool for you. It's not supposed to be an end by itself. You're not supposed to go and try to learn the math from this class. You're supposed to use it. If you're having difficulty with the calculations, please let me know, and we should work out at least a way of doing it with ease, because the thing we want to come up with is how we can calculate things. Okay, so let me first of all pull this screen in here. Let me switch to this one. Let me introduce a new page. Let's call this one page applications. Okay. Let me share it with you guys so that you guys are looking at the same thing. Does everybody see where it says one applications, one note? And it says applications Monday, August 23rd in here. Because I'm sharing it with you guys.
Yes.
Okay, very good. At this point, what I want to ask you guys to do is pick a piece of paper and a pen, just like I'm doing in here, and you start doing the calculations, and you open your book on page 8, so that we can do some questions in there and try to work them together, okay? I don't want you guys to watch me do things. I want you guys to do these things with me, okay? I want you guys to be at ease with these things. You don't want me to really do these things and then at the end, you guys don't know how to do this. I really want you to be at ease with it, okay? So if you look at page 8, it says quantitative problems. Those are problems that require calculations, okay? So those are the things that we're going to be focusing on. Is everybody ready? Or at least some of you are ready to start this. I'll give you a moment to grab your book and also grab a piece of paper and a pen, because I already have my pen, and the piece of paper is going to be the screen that you guys are looking at right now. And we're going to do question 11. Yes? Sounds good? I did not hear anybody who's ready yet. I really need to make sure that at least one person is ready to do this part. Okay, at least one person is ready. So I know one of you guys joined us late. You are supposed to do to watch the recording up to this minute because there was already a couple of items of discussions that you really need to include them in here. Okay. So question 11, and I'm going to read it to you guys because probably some of you still do not have the book yet. Okay. What would be the circumference and diameter? It gives you in parentheses the circumference is equal to pi times the diameter. So the book says the circumference, usually in symbol notations, the circumference is used C for it, the letter C for it. So if I have a sphere in here, so think of this one as a sphere. Let me pull it. Here is an example. This is a beat up soccer ball because we played with it yesterday. We play with it all the time. So, okay, so this is a sphere. So the circumference, so what is the circumference? It's basically this distance. It doesn't matter which direction you go to. In a sphere, it's the entire distance. So if I start from here, I go around and come back to the same point in here where I started from. So if I start from here, I go whichever direction I go to, as long as I am on the big circle in here, I come back in here to the same point where I started from. Okay, I don't know where I started. I was not paying attention. But the point being in here is your starting point is your ending point. So that is what the circumference is. So the circumference is equal to pi. And pi, if you don't know, is just a number, 3.14. Okay, that's what pi is, okay? Times the diameter. And the diameter is this distance. If you puncture the ball from here and go all the way to the other side, and I really don't want to do that because it's still a useful ball. So if we puncture it from here and go to the other side, that is what the diameter is. So the formula we use is called C equals to pi times D. Did any one of you see this formula before in the past for the circumference? Yes, maybe? Yeah. Okay, very good. So it's something that some of you have seen of a ball would represent the moon if the earth were a volleyball. I don't have a volleyball, I have a soccer ball. So if the earth were a soccer ball, or a volleyball, which is slightly bigger than the volleyball is slightly less actually. I don't have a volleyball. So I have a soccer ball. What kind of a ball or object would this or object matches the size of this one? So what they tell you in the previous problem is, if you look at the previous problem 10, if you use a volleyball as a model of the earth, how big would the 1 kilometer be? The volleyball circumference is 68 centimeters. So they tell you the volleyball is 68 centimeters. In what? In the circumference. So that's the circumference of the ball. Okay. And what we want to do is we want to find the diameter of the ball. So the diameter of the ball from this formula simply would be divide by pi, divide by pi. When you divide by pi, the pi cancels from this side. So that gives me the diameter on this side of the equation is equal to the circumference divided by pi. And if I have a calculator, I can plug in the numbers and find what 68 divided by pi is. What 68 divided by 3.14 is. Does anybody have a calculator? Tell us what this number is. Can anybody do this calculation for us? Yes, no, maybe? 21.65. I'm gonna make it around 22 centimeters. Is that okay? Closer to 22. We're just roughing it. We're just coming up with rough numbers. We're not really being, if I really want to be careful and I want to use this ball, honestly, I really have to use a ruler and try to find the circumference. First of all, this ruler is not going to give me the entire circumference, but what I can do, actually, I can find the it's roughly around 21. You really are right. It's really around this number in here, okay? So it's around this number in here. Probably I should flip it so that you can see it right. So it's around 21, 22 centimeters. So I'm gonna rough it around 22 centimeters, okay? This is, it should be, I give you the formula and you're supposed to come up with this one. So this is basic calculations. William? And I'm being a little bit more verbose and more detailed than skipping the steps. Does this help, William, or?
I've never done like math like this, that's why.
Okay. Did you, I know it's not required to have a math, so if you have difficulty with this one, please let me know, okay? So, okay, so we have the diameter, which is just dividing 68 by 3.14. So it's a matter now of finding the 22 centimeters corresponds to the diameter of the Earth, okay? This is the Earth. So from here to here, that is the diameter of the Earth. The Earth diameter from the table, if you look at it, it's about 12,800 kilometers. So 22 centimeters is about 12,800 kilometers, okay? You guys see that? The moon's radius is about a quarter of that. Quarter of this one. That is, if you read the chapter again, it tells you about a quarter. So the moon must be quarter of that. So quarter of 22 is slightly more than 5 centimeters. Because if we divide 22 by 4, it's going to be 5.5 centimeters, slightly more than 5 centimeters. Okay. So the moon must be about 5.5 centimeters, which should be around an apple. Okay, so that is about the apple. So if you want to picture the Earth and the moon next to one another, here they are. So when you are on a total eclipse, you really have to be, and we're going to talk about that one, under the shadow of the moon, because if it happened at total eclipse in here, it does not happen in here or the other sides of the Earth. Does this make sense to you? This is an apple, by the way. Can you visualize this? Yes? No? Come on, guys. Does this make sense?
Yes.
Okay, very good. So basically what we did was we calculated the diameter of the Earth, which is just dividing by pi. And once we found that, we divide the answer by 4 still, because the moon's radius is about a fourth that of the Earth, meaning its diameter is also about a fourth that of the Earth. And we ended up with an apple, basically. So if the Earth were a soccer ball, the moon is actually an apple, okay? And I know when you go outside tonight and you look at the moon, it looks big, but it's still very, very small compared to the Earth. Think of a soccer ball versus an apple. They put them next to one another and you can visualize them. So these questions, question 11 is an interesting question. It's immediately related to question 10 actually, because we did actually question 10 also in the same token, because we put how much a kilometer would be represented in terms of centimeters. So this is called the scale. So we scaled the Earth, which is this big, to that of a soccer ball. Okay, we scaled it down. Okay, and in doing so, we have to scale also the moon accordingly. So the moon cannot stay in its own size. We have to reduce its size to have a match. Now we have we can visualize things. Okay, so this is the type of calculations that is in your book actually, and that you are supposed to have to be able to do, and we should have no problem basically going through this ones. Similarly, if you open your book on page 16, actually, for this page, you really need to look at page 14 in the book. Again, page 14 in the book gives you table 2.1. I made a big fuss over this one in the recordings that you guys are supposed to look at this table. And in this part, you are supposed to take a nickel, okay, and think that the nickel is actually the Milky Way. If the nickel were the Milky Way, it turns out you can basically see how much the local group is going to be, and the local group is going to be about a city. This is nickel is the Milky Way, which is a big object. The entire city of El Centro will be the local group where all of the galaxies are. So again, this is similar fashion, except it uses the light year instead of kilometers and things like that. So if I look at the question 10, if the Milky Way, so I'm looking at page 16 now, which is unit 2. If the Milky Way were the size of a nickel, about 2 centimeters in diameter, so let's check this thing here. The book is saying it's about 2 centimeters in diameter. Is it? I have my ruler and I have the nickel in here. And you can clearly see it's covering about 2 centimeters in it. So the number that you see behind is actually the number 2 in here. So it's about 2 centimeters. So the book is right in here, okay? So this thing is about 2 centimeters from end to end on this side, okay? So this is the nickel. It's about 2 centimeters in size. How big would the local group be? The local group, if you look at the table 2.1, which is page 14 again, page 14, it says the local group radius, not diameter, is 1.5 million light years. So are we still sharing the screen? Yes, we are. Good. Should really have stopped sharing the screen to see the measurements, but hopefully you guys have seen it, okay? So, where is my pen? Where did I put the pen to right when on the screen? Sorry about that. Sometimes I misplace this pen. It's an important pen because that's the only one that can write on the screen. Oh man, that's funny. Sorry about that. Okay, so let me read the problem while I'm doing that, and hopefully you guys have the book also so that you can read it. If the Milky Way were the size of a nickel, about 2 centimeters, we can type still, okay? I can still type on the screen if I cannot write it down. So I can come in here instead of a drawing, or I can use the mouse for that purpose, which is going to be bad, but we're going to use the mouse for it now. So if the Milky Way were the size of a nickel, which is about 2 centimeters, how big would the local group be? So let's look at the size of the Milky Way first. The Milky Way, if you look at the table, it tells you that it's 50,000 light years in radius, which means that its diameter is 100,000, that's a zero supposedly, light years. So this is the diameter, and this is represented by a nickel, which is 2 centimeters. So this is the Milky Way now. So we are scaling the Milky Way as the size of a nickel. Now what we want to do is we want to know how big is the local group. The local group is a bunch of galaxies in our neighborhood, about 40, 50 galaxies in our neighborhood. The three biggest ones are again Milky Way, Triangulum, and also Andromeda. Okay, and the Magellanic Clouds, both of them, the small and the large. Okay, so we have the local group is 1.5 million. So is it 1,500,000 light years? And this is just the radius. So I have to multiply this by 2 to get the diameter. The diameter is always twice the radius. So this is 3 million light years across. So the question is, how big is this? So what I do in this case is 3 million times 2, that's 6 million divided by 100,000. And the answer is going to be 2 times, so let me do the calculation quickly in here. So what I can do in here, I divide 300 or 3 million divided by 100,000, and that is going to be 30. Test it on your calculator. It's going to be 30, because 3 million divided by 100,000 will cancel 1, 2, 3, 4, 5 zeros, because I have 5 zeros in here. So it'll be left with just 1 0 and 3. So it's going to be 30 times 2, because remember, it's 2 centimeters for 100,000. So that means that it's going to be 60 centimeters. So if this were the Milky Way, I don't have 60 centimeters. I have only 30 centimeters in this ruler. So if this were the Milky Way, I will have twice as much this. So I'll have this much plus an additional amount like this one. So this will be the extent of the local group. This is the local group. This is in our neighborhood. So somewhere in here, there is Andromeda. Somewhere in here, there is Triangulum. And in between, there are a bunch of other galaxies, okay? So that would be answer to part 1, part A. How big would the local cluster, supercluster is? So if I look again at the table, it says the local supercluster is about 50 million light years in a radius. I have to multiply that number by 2 to get 100 million. So the local cluster is 50 million, which is 50 followed by 6 zeros. I have to multiply that by 2 because this is just the radius. And I have to multiply it by 2 to get the diameter. So if I do that, it's going to be 100 million. Light years. This is the local cluster. So the local cluster versus the galaxy, which is 100,000, 100 million divided by 100,000, that is going to be 1,000. So it's going to be 1,000 times bigger than the galaxy. And the galaxy is only 2 centimeters. So 1,000 times 2 centimeters gives me 2,000 centimeters. 2,000 centimeters is, because centimeter is 100 centimeters is a meter, so it's about 20 meters. So if this were the galaxy, 20-meter way is the local supercluster, and that is really a big structure. It's actually slightly bigger than the average house. 20 meters is a very big one, okay? It's the backyard. So drop a nickel there, that is the other galaxies in our neighborhood. That's an interesting problem because it's giving me all kinds of questions in here that I can answer for it. And then, how big would the visible universe be? If I look again at that table, and again, we're relying on table 2.1, it tells me the visible universe is 13.8 billion light years. Oh man, we're talking about a big thing. And this is in radius. So I have to multiply that by 2 again to find the entire diameter. So again, for some reason, I'm not finding my pen, so I'm going to use a mouse still. So it's 13.8, 13 billion, 800 million light years, and this is just the diameter. I mean, the radius, I'm sorry, I have to multiply it by 2 to get the diameter of the visible universe. So this is just the radius r, and I have to multiply the radius by 2 to get the actual diameter. And that gives me 13.8 times 2. If I multiply 2 by 8, that's 16. If I multiply 2 times 3, that's 6 plus the one number I retained from here, that's 7. And then 2 times 1 is 2. So it's 27 billion, 600 million light years in diameter. So if I divide that by 100,000, I cancel the zeros. And I will be left with 276,000 times. So it's 276,000 times bigger than the Milky Way, because I divided by 100,000. I have to multiply it by 2 centimeters because the Milky Way is 2 centimeters by itself. And if I do the calculation, it's going to be 550 basically, because 2 times 6 is 18 again. 2 times 7 is 14 plus the 1 I retained in here, that's 5. 2 times 2, that's 4 plus the 1 I retained from here, that's 5,000 centimeters. Remember, a centimeter has 100 centimeters is 1 meter, so it's 5,500 in 80. 5,500, sorry, in 80 meters. And 1 kilometer has 1,000 meters in it. So if I divide by that, it's going to be roughly about 5.5 or 5.6 kilometers. So if this were the Milky Way galaxy, across town is the universe, the visible universe. So this is problem 10. And I know I went very much in depth for these problems. And I probably will post it in a simplified version for you guys so that you can see how that looks like. And hopefully you can have an understanding of how these things work. Any questions about these 2 problems? No? Okay, so again, I'm going to post actually the solutions for these 2 problems for you guys to look at. When you are doing these problems, this is not an exam. This is not, you are supposed to work together. You are supposed to look at the resources. You are supposed to Google stuff. So there will be homework related to these questions, okay? Where you can do the math. Now, if for some reason you cannot do the math, for some reason you have problems with doing the math, you can reach out, you can ask me, and I will help you, and we'll get it done, okay? Because the point of this assignment is for you to understand how these things are done and appreciate what they mean, basically go beyond that. I don't want you to be sitting in front of your screen or in front of your book, frustrated, not knowing how to do the math, and then at the end, you don't get anything out of it. That is really the last thing that we should have in this class, okay? So I want you really to be at ease with these things. and make sure that you understand these things thoroughly and you have no difficulty with it whatsoever. Okay. So again, you will have assignments from this book, and you are supposed to do these things. You can grab a person or two or three, depending on the people you work with. Meet online, and if you have to meet in a safe fashion, you can meet together, as long as you meet all the requirements in terms of safety and health guidelines. If you do that, then work together. Okay, you are encouraged to do so, as a matter of fact, because science, part of the scientific method, which is coming in the other units, is a collaborative endeavor. People work together. No one person can do everything on his or her own. You have to work in teams. Okay, so you need to learn to do that. That is actually a skill that you can take actually to a workplace and work with people and basically to get things done, because you cannot do everything on your own. So again, you're encouraged to work in teams to do these problems. And if you still have issues, and you can research actually the materials, and if you still have issues, reach out to me so that to complete your assignment and be happy with it and you have full strength with it. Make sense?
Yes.
Yes, absolutely. Thank you very much, Natalia. That's the answer to your question also in the chat. Yes, you can reach out to your classmates and work together. This is absolutely something that is actually encouraged. So that's the third item of the discussion today. We're working collaboratively to doing these problems and the homework that you can work in teams and submit them. And at the end, even at the beginning, you can reach out to me for help on these things. Make sense? So that is item 3. So we have a plan now.
Wait, item 3 to enter at the discussion.
This is the third item to add to the discussion, how to work out problems from the book, the assigned problems, okay? Because there will be assigned problems. And the way to do these things is try to work in teams. You're not required to, but try to work in teams. Research and ask for help before, during, and after. Good?
Okay, thank you.
Okay, thank you very much. That's the item of the discussion, the third one, actually. And the radius of the sun. Okay, let's do one more, okay? And that's what, oh, I found it. It was all along here, I'm sorry. Okay, so let's do one more, okay? I'm gonna pick up the red color in here. Oops, still green. Okay. So for this one, we're gonna do problem 9 and see what that means, because it's important. It says your problem 9 again from the book. So a few minutes, so we're good. It tells you the radius of the sun is 7 times 10 to the power 5 kilometers. This is one thing which is important, which is the scientific notation. And I know I made a big fuss over it in the recording, so hopefully you guys will watch it. So this is the radius of the sun. Radius of the sun. R stands for radius because I'm lazy. I don't want to write the whole thing. I'm just writing R.
You're not sharing the screen.
Am I not? I'm sorry. Thank you very much. That happens a lot. So I'm glad that somebody was here to catch me. Okay, so the radius of the sun is 7 times 10 to the power 5 kilometers. That's the radius of the sun. And the Earth is about 6.4, 10 to the power 3. So the radius of the Earth is 6.4 times 10 to the power 3 kilometers. That's the two radii to one another. Show that the sun's radius is approximately 100,000 Earth radius or Earth radii. Okay, so what I do in this case is I do the ratio of the two, that's all. take the ratio. So I will know the radius of the sun versus that of the earth, which gives me 7 times 10 to the power 5 kilometers divided by 6.4 times 10 to the power 3 kilometers. When I'm doing these ratios, I have to be very careful with the units. I cannot use different units in here. I have to use the same units so that they cancel out. Because if I use the different units, then I have to convert. Since I'm using kilometers for both, so I can safely cancel this too. That is an important step when you're doing this kind of calculations. So step one, make sure you're using the same units. Most of the times you're going to be given the same units. If you are not, that is the time when you have to really raise a red flag. Hey, they gave us the radius of the earth in meters and the radius of the sun in kilometers or in light years or AU as astronomical units. So we need to convert first. We cannot compare apples to oranges. We have to compare only apples to apples, okay? Or oranges to oranges. That is really the essence of it. You cannot tell me if an apple is this times whatever compared to this time apple-y compared to the orange, or this time orangey compared to the apple. We really have to be comparing the same thing. If we want to compare the size of the two, I have to give the size of the two in the same units. Okay, then I can tell you which one is bigger. Okay, I cannot tell you which one is more orangey because probably that property doesn't exist in the apple, and vice versa. Okay, same thing in here. So I have to make sure that the units match before I do the calculations. The other thing also is that when you do the powers, when you take a power divided by a power, you subtract the exponents, that's all. So this is a basic algebra property. 10 to the power 5 over 10 to the power 3. What you do in this case, it's the same thing as 10 to the power of the difference. Usually, not usually, always, the one on top keeps its sign. So if it was positive, stays positive. The one in the bottom changes signs. It was positive, now it becomes negative. That's all. So if it was negative, then it becomes positive. That's all. So the one on top keeps sign. The one in the denominator changes sign. Because both of them are positive, the one on top stays positive, the one on the bottom becomes negative. So this is clearly 10 to the power 2. Because 5 minus 3 is 2. And 7 divided by 6.4, it's roughly 1. If you put it on the calculator, it's going to be slightly more than 1. Actually, let me try to pull a calculator in here and see what that number is. So I'm going to pick up a calculator that I use. It's a handy dandy calculator. I have it on my computer. And I will stop sharing. Okay, let me stop sharing that screen. And let me share with you the calculator itself. And I'm going to take 7 and divide it by 6.4. So this is the division. If I do division, it's 1.09. 375 if you really care about it. So this part is 1.09 something, which is roughly 1. Slightly more than 1. I'm sorry, not 10. Slightly more than 1. That's all. Times this ratio, which is 10 to the power 2. And 10 to the power 2 is 10 times 10, which is 100. So the answer, radius of the sun versus the radius of the earth, is roughly, not exactly, roughly 1 times 100, which is roughly 100. So that is the answer to the question. So the question says, the radius of the sun is 7 times 10 to the power 5 kilometers, and that of the earth is 6.4 times 10 to the power 3 kilometers. Show that the sun's radius is approximately 100 times the earth's sign. And this is exactly what we have shown. We have shown that the sun's radius is about 100 times more So if this were the sun, the apple won't do because the apple is actually just a quarter of it. So I really have to take something that is 100 times less. And remember, the radius of this guy is about what? What did we find earlier about it? The radius was about 20 something, 22 centimeters. So 22 centimeters divided by 100, it's going to be 0.2 centimeters. The 0.2 centimeters is less than the width of this thing in here. Which one in here? Trying to find something that is about 2 millimeters in width. This is less than 2 millimeters. So this is the width. I'm not talking about the length, okay? The width only. It's about the Earth. Less than that, okay? Less than this distance. That is the Earth compared to the sun, okay? Of course, the volume will be 1,000, will be 100 times 100 times 100, which is because the volume is the cube. So you have to multiply it by 3 times. 100 times 100 times 100, which is put it at a million times bigger. So in other words, you can take this, if this is the sun, you can put 1,000,000 Earths in it, okay? So those are the problems I wanted to share with you. I'll post them again on Canvas for you guys. And that's what I wanted to share with you today. So basically, you have 3 items of discussion. 2 of them have to do with Stellarium. And one of them has to do with the working standard when it comes to these problems. And as I promised, this is really the 3 types of assignments you will have in this classroom. Discussions, and then and then also the what was the other one? I forgot now. The concepts that you're responsible, because you will have quizzes based on those concepts, okay? You will be quizzed on those concepts. So you have to really make sure you do the readings and also follow the discussions that, the recordings I have after that. So you really have to understand those concepts because that's actually the bulk of things. And also part of your assignments will be to do actually the some of these problems that I'm going to be posting in here, okay, for you guys. I'm going to post those and how you handle them. Yes, you do have 3. And then the how you handle these problems is working in teams if you can. Okay, if you can. So you can form a team and start working with them. The only recommendation I have to make sure for this team working says you have to pull your weight. You have to basically do your part. You cannot rely on some other people to do everything and then you come in and copy their work and tell me you're working in a team. Yes, you are part of the team and yes, you are going to get a grade, but you're not benefiting anything from it. Every team member has to do his or her share of the work so that you really benefit from the work and you get it together. Now, during, before, and after, you can always ask for help because I don't want you to be sitting frustrated in there, not knowing what to do, okay? Because that's the last thing that you should really have in this thing here. If you do all of these things, you should be ready for your quizzes, exams, and even the projects, and you should not have any problems whatsoever. This is basically concludes how the day-to-day things are going to be happening in this class. Any questions for me? If not, we exceeded the time allotted.
I don't know if you mentioned this, but did you say you were going to write the questions in the discussion?
I'm gonna put them actually separately. I'm going to post these questions, the ones that we did today, to serve as an example for you guys on how to work things down the road.
Okay.
Okay? Okay. We exceeded our time and I have another class that is starting in a few minutes. So I'm sorry about the problem that happened earlier with this link. And I will post this one hopefully tonight, okay? Thank you guys. Let me stop the recording.